Alright, welcome to our lesson on electric charge and static electricity. In your books, it's Chapter 2, Section 1. Alright, before we begin, I want to make sure that everyone's on the same page as far as parts of an atom. So take a look at the diagram and review the parts of the atom and the subatomic particles, those little particles that are flying around in the diagram. You will notice the yellow particles in the center with a plus sign on them. Those are positive charges called protons. The orange particles in the center are called neutrons. Now, protons and neutrons are found in the center of an atom in the nucleus. So that is where the nucleus of an atom is. So you have a positive charge and a neutral charge. It has no charge, the neutrons. So generally, the nucleus of an atom, the very center, has a positive overall charge. Now, surrounding the nucleus are little tiny electrons that spin around, they circle around the nucleus. You can see that on each of those little tiny electrons, they have a negative sign on them. Those, again, are called electrons, and they move around the nucleus, and they have a negative charge. Now, in a stable, happy atom, there is the same amount of positive charges on the inside, the nucleus of the atom, as there are negative charges surrounding it. So overall, this charge, assuming it has the same amount of protons with a positive charge as it does electrons with a negative charge, this atom overall has a zero charge. If you think of +1, -1, the atom together, you have 0. So if you have a positive, one positive charge plus one negative charge, you have 0. So if you have 5 positive charges plus 5 negative charges, you have an overall charge of 0. So this atom is stable. It has the same number of protons in the nucleus as it does electrons circling it. So the overall charge of this atom is 0. Alright, so as long as you understand that concept, we're ready to move on. Alright, so the first topic we're going to talk about is electric charge. Now, electric charge, the definition, is a property of electrons and protons. Protons and electrons have opposite charges, just as you saw in the atom on the previous slide. The charge on a proton is positive, so you can say it is a plus charge, and the charge on an electron is negative. Now, charges that are the same repel each other. So if you have two atoms that overall have a positive charge, they will actually repel each other. On the flip side, charges that are opposite attract each other. So if you have a positive charge, one positive charged atom, it will automatically be attracted to a negatively charged atom. So they actually attract each other. So opposites attract. So if they are the same charge overall, they will repel each other. But if they are opposites, they will actually attract each other. The interaction of charges is called electricity. Alright, let's talk a little bit about electric force. Electric force is the attraction or repulsion between electric charges. An electric field is a region around a charged object where the object's electric force is exerted on another charged object. So an example would be if you had an atom that had more positive protons in the nucleus than it did negative charges of those electrons. So if it had more positive, it would have an overall positive charge. Well, it would repel or a overall negative negatively charged atoms. So each of those are charged atoms if they have an overall either positive or negative charge. So they would have what we call an electric field, a region around those charged objects where the object's electric force is exerted on other charged objects. When a charged object is placed in an electric field, it will either be pulled or pushed away. It will be pushed away if the charges are the same, like we said earlier, two objects that have the same charge, like two positively charged objects, will push away from each other, or they'll be pulled towards each other if their charges are opposite. So anytime you have a charged atom, whether it has more protons in its nucleus than it does electrons surrounding it, there it would have a positive charge, or if it has more electrons surrounding it than it does protons in its nucleus, then it would have an overall negative charge. And that's pretty common. Electrons tend to be kind of loosely, they kind of float around from one object or one atom to another, so sometimes different types of substances will hold on closer to their electrons than other objects, but it's pretty common to have positive and negative charges working at all times. Alright, an electric field around a single charge. Alright, electric field. So again, if something is charged, meaning it has a different number of protons than electrons, it's going to have a charge. Whether it has more protons than electrons, it'll have positive, or if it has more electrons than protons, it'll be negative. But we draw electric fields around them, and they are invisible, but we can draw them using lines. They are drawn with arrows to show the direction of the electric force. So you can see in the diagram, there are arrows pointing away from a positive charge and arrows pointing towards a negative charge. This is just how we draw them. Alright, electric force always points towards, or always points away from positive charges and towards negative charges. And that's just kind of the push and pull effect. So a positive charge tends to have a pushing effect, and a negative tends to have a pulling effect. So you can kind of see why they are generally attracted to each other. Alright, the strength of electric fields. The strength of an electric field is directly related to the distance from the charged object. Alright, the greater the distance, the weaker the electric field. So the further away you are from that charged atom, the weaker its electric field is going to be. The strength of the electric field is represented by how close the lines are drawn to each other. You will often notice, and I don't believe I have a picture of this, but you will notice when you draw those electric field lines, they will be really close together when you are referring to the center or closest to that particle. The lines will be really close together, and as the lines move away from the center of the charged object, they tend to spread out, and that just kind of demonstrates that as you move further away from a charged object, their electric field gets weaker. Alright, the lines, they are drawn closer together, nearest the charged object, and spaced apart further from the charged object. Alright, and you can kind of see this on the next slide. You'll notice that closest to the plus and minus, the actual charged object, whether it's a plus or a positively charged object or a negatively charged object, you can kind of see from the diagrams below that the closer you are to the object, the closer the lines are, just meaning it's a stronger electric force. Alright, electric fields around multiple charges. When there are two or more charges, the shape of the electric field gets altered. The electric fields of each individual charge combine by either repelling or attracting. So you can kind of see the positively charged atom or object and the negatively charged atom or object, once they get close to each other, their forces kind of combine and they link up, because a positive and a negative opposites attract, so they actually kind of come together. Now on the second diagram here, you'll see two positive charges, and you will see that their electric fields actually repel each other, so they get pushed apart. So, you know, two like things don't often come together. So, and this is the exact case for that. So, two positive charges, you know, will repel each other. All right, static electricity. We're just going to skim through this a little bit. It's one of those topics that fits into this section nicely. So most objects have no overall charge. They are neutral. They have the same number of protons as electrons. That means it's stable, it's happy. But sometimes objects lose their electrons. Remember, electrons circle around the nucleus of an atom freely. So those electrons, those little tiny charges that circle around the nucleus of an atom, they can get transferred from one atom to the next. So, and it just depends on the different material, whether that element or whatever type of atom that it is, some atoms will hold on to their electrons or keep them closer to them and hold on to them, and other objects kind of have a loose hold on them and they can get transferred to a different atom quite easily. So it just depends on the element, and we will talk in a later chapter which types of elements or atoms actually lose their electrons pretty easily. All right, so if they lose their electrons, a substance that loses their electrons has an overall positive charge, because remember, it's losing those negatives, giving the atom an overall positive charge. Common in things made of silver, copper, gold, and aluminum, I guess we'll talk about this a little bit now. Based on their composition, they're metals. Generally, metals tend to hold on to their electrons pretty loosely, and they make really good conductors, and we'll talk about conductors a little later as well. But usually, these types of metals will get an overall positive charge because their electrons are held on really loosely, and they can get transferred from one atom to the next pretty easily. Sometimes objects gain electrons and then have a negative charge. So kind of just keep that in mind. Now, static electricity, more about it. Static electricity is the buildup of charges on an object. So that is called static electricity. Static means, the meaning of the word static means not moving. So if something is static, it's not going anywhere, or it's not changing. So if I tell you your comprehension or your ability is static, it just means that you're not changing or you're not growing or getting better. So that's just the meaning of the word static. In static electricity, charges build up on an object, but they do not flow continuously. So they build up, the charges build up, but they can't go anywhere. So it kind of creates a little bit of an issue. All right, so you can kind of see in this diagram, charges build up, but do not move in the world of static electricity. So you can see on the left side of this diagram, there's a buildup of negative charges. So those are the atoms that have all the electrons. And then on the right side of this diagram, you'll see that there's a positive charge, or they've lost their electrons. So and they're not going anywhere. They're just kind of staying there. So you've got a negative charge and a positive charge. So that's static. They're static and unchanging. Now, transferring charge. An object that becomes charged only when electrons are transferred from one location to another. So that's when it becomes charged, when the electrons are either moved from the atom or they've gained electrons. So if they've gained electrons, they get an overall negative charge. If they lose electrons, they get an overall positive charge. The law of conservation of charge just says that charges are neither created or destroyed, just kind of like our conservation of energy. They're always transferred, never created or destroyed. So charges are just transferred. There are three methods by which charges can be transferred to build up to static electricity to where it will not change or flow continuously. So three methods. You have friction, conduction, and induction. So we're going to talk about all three, and we got an example that's going to kind of tie all this together. Alright, so charging by friction. Charging by friction is the transfer of the electrons from one uncharged object to another by rubbing. So please keep in mind the term rubbing. Think about, if you're walking on carpet and your feet are rubbing on the carpet. So that is charging by friction. When two uncharged objects rub together, electrons from one object can move onto another object. The object then that gains electrons is then negatively charged, and the one that loses the electrons is positively charged. So take a look at this example, charging by friction. Electrons are rubbed from the carpet to the girl's sock. The charges are distributed evenly over the sock. So you can kind of see that the electrons are going from the carpet to her sock, so giving her sock an overall negative charge. Alright, so now charging by conduction. When a charged object touches another object, electrons transfer from the object that has a more negative charge to the object that has a more positive charge. So it's always going to go from an object with more of a negative charge to an object with a positive charge. Charging by conduction is the transfer of electrons from a charged object to another object by direct contact. So conduction, the definition of conduction is when something is transferred by direct contact. So charging by conduction is just that transfer of electrons. So whatever object has more of a negative charge will then, if it touches an object with a positive charge, those electrons are going to move to the positive area. Alright, so back to our example, you saw by the last slide, charging by friction, the negative charges from the carpet were then rubbed and then transferred to her sock. Now charging by conduction then, when the negative charged sock touches the skin, electrons are transferred by direct contact. Electrons are then distributed throughout the girl's body. So because her sock had all those negative charges from friction, it gathered up all those electrons, and her sock became negatively charged. Now her sock is in direct contact with her foot. So those extra electrons are now moving from her sock to her foot by conduction or direct contact. Now, charging by induction now is when objects do not touch. So in both friction and conduction, they had to be touching the objects for those electrons or negative charges to move from one object to the other. They had to be touching. By induction, they don't actually have to be touching. Charging by induction means the movement of electrons to one part of the object that is caused by the electric field of the second object. So remember, any charged object will have an electric field or a force. Now remember, if it's an electrical field, it's going to have that pull towards it. If it's a negatively charged object, it's going to have that pull towards it. If it's positively charged, it's going to have that push away from it. So induction is the movement of electrons from one object to the next by the electric field either pulling or pushing. Now, the electric field around the charged object attracts or repels electrons in the second object. Now, you can see here in this example, the girl's finger is not touching the doorknob, but you can see that the negatively charged particles on the girl's finger, because she got the negative charges from the sock, it transferred by conduction from the sock to the girl, then distributed throughout her body. Now she's got the negatively charged particles on her finger. Now she goes to touch a doorknob, her finger has that overall negative charge, and that electric pull, that electric field around her finger, because it's negatively charged, is going to have an effect, an induction effect on that doorknob. So charging by induction, electron on the girl's fingertip produce an electric field that repels negative charges and attracts positive charges on the doorknob. An overall positive charge is induced on the edge of the doorknob. Okay, so read that again. An overall positive charge is induced on the edge of the doorknob. All right. Now, how do we detect charge? Alright, so electric charge is invisible, but it can be detected by an instrument called an electroscope. It consists of a metal rod with a knob at the top and two thin metal leaves at the bottom, and you can see the diagram to the left, or I'm sorry, to the right of a electroscope. Now, when the electroscope is uncharged, the metal leaves hang straight down. When a charged object touches the knob, electric charge travels by conduction into or out of the leaves. Alright, so we'll kind of just take a look at this electroscope on the right here. Alright, so as the balloon is removed, the positive charge, okay. Now look, at this point right here, the electroscope is neutral. As a negatively charged balloon is brought near, electrons in the electroscope move from a plate. The neutral ground is touched into the needle area, allowing electrons to flow out of the electroscope. Having lost electrons, the electroscope now has an overall positive charge. As the balloon is removed, the positive charge becomes uniformly distributed. The electroscope is neutral again. So they removed it. Alright, now static discharge. When a negatively charged object and a positively charged object are brought together, electrons are transferred until both objects have the same charge. So this is kind of what happened in the last diagram with touching the doorknob. Remember, the girl's finger had an overall negative charge. The doorknob had a positive charge. So when a negatively charged object and a positively charged object are brought together, electrons are transferred until they are both the same. So what happens is what's called static discharge. It's the loss of static electricity as electric charges transfer one object to another. So when that girl's finger touches the doorknob, they have opposite charges. So the finger is actually negatively charged, the doorknob is positively charged. Those electrons actually try to transfer to the positively charged area, and then you get that little shock. It's a static discharge. So that's what you feel when you feel that static shock. Alright, here's what I want you to think about. You have the ability to go back through the slides, to move back through the video, to review, to look back at concepts that maybe seemed unclear, go back through and read it. Here's what I'd like you to do. On a separate sheet of paper, answer the following questions. Refer back to the presentation to help you. Alright, so here's your question. Question 1. What are two types of electric charge? What charges can an object have? There's only two. Question 2. How do objects with the same charge interact? How do objects with different charges interact? So if they have the same charge, how do they interact together? If they have different charges, opposites attract, right? Write your answer on your paper. Number 3, what is an electric field? Question 4, research. Lightning is a form of static discharge. Can you explain this? You have the ability to get on the internet if you're using the laptops. Look it up. See what you come up with. It is a form of static discharge, and we will talk about it in class, but I would like to see if you can tell me, based on what you know about static discharge, if you can come up with what it is. Can you explain lightning?